Welcome to the course Introduction to Scientific Programming and Machine Learning with Julia. My name is Antonello Lobianco and I am the founder of this collaborative, interactive and multi-channel course. So, scientific programming and machine learning can both mean a lot of things. What exactly is in this course? Let's go into see it. At the time of recording, the course comprises an introductory unit and 4 thematic lessons. The introductory unit starts by answering the question on why should I put the effort into learning yet another programming language? What's special in Julia compared with older languages, at least from the perspective of a data scientist and a researcher? Hence, it highlights the main characteristic of Julia, but will then be discussed in the next units. It then provides guidance on setting up a Julia development environment and, for those that need it, a crash course on Git, as the Julia package manager is strongly coupled with Git, with many nice properties of Julia resulting directly from it. And note that modules, packages and environments and the wider topic of reproducible results are so important in Julia's that they are already discussed in this introductory unit. The unit concludes by introducing the topic of machine learning, defining its scope, providing examples and clarifying the terminology. So don't skip this introductory unit, it is rather important. The first thematic unit, Julia 1, is a gentle but rather deep introduction to the Julia programming language, its syntax, the data structure that it provides by default, how to implement custom types, but also more advanced topics such as metaprogramming and some hints to parallel computation. This is by far the largest unit of the course with almost 6 hours of videos. The next unit, Julia 2, deals first with data wrangling using the DataFrame package for in-memory tabular data, including the split, apply, combine strategy. After we become comfortable with manipulating data, we learn how to use the distribution package for making probabilistic models, the LSQFit package for fitting any generic curve with data, and how to visualize this data with the plots package. The unit concludes with the topic of constrained optimization by showing how to implement complex constrained optimization models using the JUMP algebraic modeling language. The third thematic unit, ML1, provides an intuition to many machine learning concepts, including supervised learning, cross-validation, and regularization. We also go deeper by implementing ourselves perhaps the simplest machine learning algorithm, the perceptron linear classifier. Finally, the fourth thematic unit, NN, discusses neural network models, how they work, what they are good for, and how to train them. Specific neural network architectures, such as convolutional neural networks and different types of recurrent neural networks, are also discussed. This unit are 2 segments. The first one remains more theoretical, while the second one implements its concepts using Julia packages. So, while there is already quite a lot of material in this course, at the time of recording 15 hours of videos, 14 interactive quizzes with 50 questions, 7 guided exercises, I hope that this is only the beginning. The course is built on top of a public Git repository and GitHub Actions, and I consider it more as a platform than as a single one-topic course, and I welcome collaborations to add its content. Please refer to the relevant section if you wish to contribute. For example, topics that I think should be important that they are present include symbolic computation, differential equations, statistical models, random forest models, clustering, reinforcement learning, and so on. The course assumes no previous knowledge of Julia or machine learning, although an introduction, even informal, in programming and in basic calculus, statistics, and linear algebra is expected. So, welcome on board, clone the repository and work on the files by yourself, or watch the videos, or just read the compiled segments with the output of the code being executed. It's up to you. In all cases, if you feel lost, don't be afraid to use the comment form at the bottom of each page. For example, you can use those at the end of this presentation to introduce yourself. Happy learning!